In this video, I'll talk about how to use the rational zeros theorem to help find the real zeros of a polynomial function and then to factor that function over the set of real numbers. In number 30, f of x equals 2x cubed minus 3x squared plus 6x minus 9. So the first thing I'm going to do is use the rational zeros theorem to get an idea of what the possible rational zeros are. Remember that the rational zeros are not all of the real numbers. That's just a portion of the real numbers, but it does help us to find the real zeros of a polynomial function, even if we have some that are irrational. In order to list my possible real zeros, I want to keep in mind that for this problem, P is 9 and Q is 2. So where do I get P and Q? P is the last coefficient in the polynomial function, and Q is the first coefficient in the polynomial function. So I'm going to find all the factors of P. Since P is 9, my factors are 1, 3, and 9. And I'm going to put a plus and minus on each of those. And for Q, my factors are 1 and 2. And I don't bother putting a plus and minus on those because that just gives us an extra long list with a lot of doubles in it. So my possible real zeros then, I could take each value here for P and put it over each possible value for Q, each of the factors for each of those. So my possible real zeros then are plus and minus 1, plus and minus 3, plus and minus 9, and then I'll take each of those, put them over 2, and I get plus or minus 1/2, plus or minus 3/2, and plus or minus 9/2. Now, I'm going to use my graphing calculator to help me test these because I've got, 12 different values here. I really don't want to type this over and over and over again. That's pretty annoying, and you paid a lot of money for the graphing calculator. It's supposed to be working for you. So, here's what we're going to do. I have typed in my function into y1 in the graphing calculator. And then I went into table setup, and I get there by pressing second and window on the graphing calculator. So second is a button that's pretty close to the top, and then window is in the very first row of keys right below the screen. So I press second window, I get to the table setup menu, and the key here is that I change the table increment. You see this little delta, which means the change. So what is the change from number to number in the table now? It's going to be in increments of 0.5. So I set that up. I started at -10, because our smallest possible rational zero is -9, and when I went through the list, I just found 1 0, and that's at 1.5, which is of course positive 3/2. So that's the only rational zero I have for this function, because I looked through, I went all the way up to +9, which is the largest possible rational value. So we've got one rational zero, and that's at 3/2 or 1.5. So now that I know that 3/2 is one of my zeros, I know that a factor of this polynomial is x minus 3/2. It doesn't look great with a fraction there, and we're going to take care of that in a minute. So we've got x minus 3/2 times something, I don't know what yet. So I'll use synthetic division in order to divide by x minus 3/2. I can use long division as well. I'm just going to use synthetic division because it's a little quicker. Now I've set up my synthetic division, and I'm going to bring down the 2, multiply by 3/2. That gives me a positive 3. Add, and I get 0. 3/2 times 0 is 0. 6 plus 0 is 6. 3/2 times 6 is 9. And negative 9 plus 9 is 0. So now what I know is that we have x minus 3/2 times two x squared plus 6. And this is where I'm going to fix that fraction there. Now this is what happens very often when you start factoring and you get a rational 0 that has a denominator other than 1. Then you have a fraction in your factor, and since we had all whole numbers or integers to start off with for coefficients, that denominator is going to have an extra factor popping up somewhere else. Kind of weird to explain, but here's what happens. So we've got x minus 3/2, and then we have 2x squared plus 6. Notice that there's a common factor of 2 there. So I'm going to factor out that 2. That leaves me with x squared plus 3. And now this 2 I can multiply into this factor, and I'll eliminate that fraction. So I have 2x minus 3 times x squared plus 3. And now my polynomial is factored over the real numbers. I know this because x squared plus 3, if I tried to factor that, that's going to give me x plus I times the square root of 3 times x minus I times the square root of 3, and those are complex roots. So this is as far as we can go, and that's my final answer.